You're looking at a CNC router. Now, it might look like a fancy washing machine, but in reality, you can fit so much spaghetti in this bad boy. Also, you can use it to program and manufacture fancy signs like the one that you see here. All right, let's break down what we're looking at here inside of the machine. So first, this body that you see right here is the spindle. It's called the spindle because it's the part of the machine that spins. Attached to the spindle, we have an assembly. We have our cutting tool. Inside of the spindle is a collet that is not visible from this view, and a collet nut that holds the collet and the cutting tool in the spindle. We also have a dust collector cover that fits onto the tool assembly and the spindle so that there is debris that is removed from the work area, and this is the hose that connects to the dust collector that is behind the machine. And let's also think about the axes of movement of the machine from this view as well. We have an X-axis that moves left to right on this ball screw on the bridge or the column. This assembly right here, this structure, is called the column, and that's what moves back and forth to create the Y-axis. Lastly, you have the Z-axis in the vertical movement up and down of the spindle itself. All right, so there's three major components of the cutting tool assembly that actually go into the spindle and do the removal of the material in the machine. The first one that we have is called a collet. So this is the sleeve that actually clamps around the cutting tool and holds it in the spindle. Now, what holds the collet in the spindle is this piece right here. It's called a collet nut. You'll see that it has these teeth in it. That allows us to use the wrench to tighten it onto the spindle. The third piece that we have is the cutting tool itself. Now, these come in all shapes and sizes. This is an engraving tool, so it has two distinct parts to it. There's the shank. This is the part that goes into the collet that's actually clamped by the collet and used to hold it into the machine. And then this is the insert. The insert's like a fancy, expensive razor blade. You got to be very careful with it. It's very sharp, so you always want to make sure that when you're holding the cutting tool, you're holding it by the shank. The first thing that you'll do to put together this assembly is you want to take the collet and you want to take the nut and you're going to assemble these to each other. So you put the two of them together like this, and you apply pressure on the back side of the collet with your thumbs and pressure on the front side of the nut with your index finger and your middle finger, and you push. And you're going to hear a snap. That's how you know that you did it correctly. Now you'll see the face of the collet and the face of the nut are flush with each other. That's how you know that you did it correctly. The next thing that you do is you take this assembly and you thread it onto the spindle. There's external threads on the spindle and there's internal threads inside of the nut. You have to hold the spindle so that you apply opposing force while you hand tighten the nut onto the spindle. Go just enough until you start to feel some resistance so that you can still fit the shank of the tool in. The next thing that we're going to do is we're going to put the tool into this assembly in the machine. If I went a little too tight by hand, I might need to loosen it a little bit, which I think that I did. I could put the shank up. Now I want to make sure I'm still holding the shank with one of my fingers while I hand tighten it enough so that I can let go and the tool is going to stay in the machine. Next, we have to tighten it even more. There's always this balance that you play. You don't want to tighten it too much because you have to be able to get the tool out of the machine. However, you don't want to tighten it too little because it needs to be tightened enough so that the tool stays in the machine while the machine is running. I've made that mistake before, believe me, it's not pretty. There are two wrenches that we use to finish the tightening of our tool into the machine. This first one is the collet wrench. You see it has these teeth on it. These teeth mate with the slots that I was showing you on the collet nut. This is an open-ended wrench. we'll take the collet wrench, and you have to go under and up in order to insert the teeth into the slots on the nut. Again, under and up. If you try to enter directly at the nut, it's not going to work. You have to go under and up. Then you take the open-ended wrench. There are flats that are on the spindle. Insert the open-ended wrench onto the flats so that there's an opposing force, and you go righty-tighty. Again, not too much, but not too little. Enough so that the tool is going to stay in the machine, but not too much so that you can still remove the tool from the machine when you're done. These are stored inside the machine on the right side. All right, let's secure our workpiece into the machine. We're actually just going to use double-sided tape. I cut 4 little pieces. I'm going to put 1 in each corner of the workpiece, and I want to make sure that these are firmly attached to each corner. And I want to be clean too. I want to limit the amount of debris that I get on these. Once you have them on there, you got to take the backing off of each one. All right, so this is the control pendant. It's basically what we use to move the machine around. I talked before about how there's 3 axes of movement. We have our X negative and our X positive. That's going to be left and right. We have our Y negative and Y positive, forward and back, and Z up and Z down in the vertical along the spindle. So I want to move my tool. I'm going to move the entire spindle and this bridge to the back of the machine using Y plus so that it's out of the way. Now you're going to notice too, there's 2 different forms of movement that you can create with the machine. Right now it's in jog mode. If I hit shift at the bottom, I'm going to switch to stepping, and it's going to make much smaller incremental moves, 0.004 of an inch. Really, really small, 0.1 millimeters. So anytime that I'm trying to dial in the position, I'm going to switch to stepping mode. But if I'm trying to make really large movements with the machine like I just was in moving the bridge to the back, I want to hit shift and I want to make sure that I'm in jogging mode. All right, right now I'm comfortable with the position of the machine, so let's secure our workpiece. I put my double-sided tape onto the bottom face. This is called a speed square. It helps us keep things square to the table with speed. So I'll take this edge and I'm going to align it to my machine table, and then I'm going to flip the part upside down. While I'm still holding the part, I want to make sure that this front edge is flushed to this edge of the square while holding the left side of the square against the table. That's going to ensure that the workpiece is properly aligned here. I'll drop the piece onto the table without applying any pressure at first so that I can move it if it needs to be made square again. Once it looks good, while holding the square in place to maintain its position and alignment, I start to apply some pressure into all 4 corners where there's tape. Usually about 5 or 10 seconds per corner. I can take my square out of the machine, and I just want to verify that this thing's not going anywhere. We're good. All right, now we're going to set our work coordinate system. These are often called work offsets as well. So what do I mean by that? In order for the machine to move to the position that we want it to move to, it first needs to know where it is. So we tell it that there's a specific location where X, Y, and Z are all equal to 0. Now, there's a previously programmed location that is equal to 0. If I hold shift and I hit number 5 here, you'll notice the machine is moving into position where it was previously set to 0. X is 0, Y is 0. Z has a safety built in, so the tool doesn't crash into the workpiece or into the machine. It stays a certain height above the surface. Now what I need to do, I'm going to set my XY0 first by moving the center point, the tip of this tool, to the front left corner of the part in the top plane. I'll jog it into the approximate position to begin. See how I'm in jog mode? And then I'm going to switch to stepping mode so that I can really dial in that location. I probably want to move it down a little bit in Z so that it's closer and easier for me to tell. So what I'm doing is I'm ensuring that the tip of the tool is exactly at the front left corner of the part. Now you'll see that there's a certain value of X and Y based off of the previously programmed home position. I'm going to reset that now by pressing XY equals 0 on the control, and I'm going to clear that coordinate and hit OK. Now my XY is equal to 0. Next, we have to set our Z. So I'm going to jog the machine, and I'm going to move the center point of the tool so that it's above the top surface of the part. And then I'm going to use this high-tech piece of paper. Get to class, kids. I'll hold shift, and I'm going to move the Z-axis down until I can't move this piece of paper at all. I'll probably want to jog it once, and then switch to stepping mode till I can't move my Z. All right, now I can't move this piece of paper at all. That's the exact position that I want to set my Z to 0. So I hold shift and I hit this key right here, and that's going to clear my Z coordinate. And then I can hold shift again and hit number 5, and now it moves to that home position that I programmed. But wait, what's this? When you plug your flash drive into the USB port on the back side of the machine, this prompt is going to show up on the control panel. You'll hit OK, and this is going to bring you to the menu that shows all the programs that are on the flash drive. Find the program that you want to run. In this case, this one's mine. You hit OK, and you'll notice a check mark that shows up next to the program so that it's selected. And then you press the number 1, and that's going to load the program onto the machine. It'll go back to this page where you see the position of the machine, and now you're ready to run it. Now that our program's loaded, the last thing that we have to do is move the spindle up so that we can put the dust collector brush on. Then we're going to close the door, and we're going to turn the dust collector on. So I'll go up in Z. Pull the brush head off the top of the machine, fix it around the spindle. There's an Allen wrench right here. To tighten the cover onto the spindle. I'll shut the door, and then I'll go behind the machine and turn the dust collector on.